Hi, in this video, I'm going to show you how to balance a chemical equation. So the idea is that the atoms cannot be created nor they can be destroyed. So there has to be same number of atoms in the product as they were in the reactant. So today we're going to do a couple of examples to balance the chemical equation. So in the first example, we have potassium chlorate decomposes to potassium chloride and oxygen. So we're going to state our atoms in the reactant. So there is potassium, chlorine, and oxygen. And there's potassium in product, chlorine, and oxygen. So there is one potassium atom in the reactant. There's one potassium atom and there's one chlorine atom in the product, in the reactant, and there are 3 oxygen atoms in the reactant. Similarly, there's one potassium atom in the product, one chlorine atom in the product, and 2 oxygen atoms in the product. So as you can see, our oxygens are not balanced. So we will try to balance the oxygens. So what is the common multiple? What is the multiples of 2 and 3? It's 6. So 2 times 3 is 6. So we're going to write 2 here and then make our oxygen 6. Chlorine becomes 2. Potassium becomes 2. So over here, since we want to make our oxygen atom, we want to make our oxygen atom 6, so we're gonna write 3 over here to make oxygen 6, and it becomes 6 like this. And then we need 2 potassium and 2 chlorine, so we're just gonna add 2 here, and it becomes 2 and 2. And now we have a balanced chemical reaction. So the second example is the combustion reaction. So here we have carbon atom, hydrogen atom, nitrogen atom, and oxygen. Carbon, hydrogen, nitrogen, and oxygen. So there's 1 carbon atom, 3 plus 2 is 5 hydrogen atoms, 1 nitrogen atom, and 2 oxygen atoms. And over here we have 1 carbon atom, 2 hydrogen atoms, 2 nitrogen atoms, and 2 plus 1 is 3 oxygen atoms. So now we will have to balance hydrogen, nitrogen, and oxygen. So first we're gonna start with our nitrogen. So let's make this 2. So when this becomes 2, our carbon automatically become 2. Hydrogen becomes 2 times 3 is 6. 2 times 2 is 4. 6 plus 4 is 10. And the nitrogen becomes 2 and oxygen stays 2. And here now we have unbalanced carbon, unbalanced hydrogen, and unbalanced oxygen. So what we're going to do is add 2 here to balance our carbon atoms. Now we have 2 carbon, 4 and 5 oxygen over here. 2 times 2 is 4, plus 1 is 5. Now we'll try to balance our hydrogen atom. So we have 10 hydrogen atom in our reactant, and we have 2 in our product. So 10 divided by 2 is going to be 5. So we're just going to add 5 here, simple. 5 times 2 becomes 10. Now we have balanced hydrogen atom as well. Now we only have an Also, we have changed our oxygen atoms, so there are 5 and there are 4 over here, so 5 plus 4 becomes 9. So now we have 9 oxygen atoms in our product and 2 in our reactant. Now everything is balanced except for our oxygen, which is 9 in the product, 2 in the reactant. So when you divide 9 by 2, you get 4.5. So you add 4.5 to bring this at 9, because you want 9 oxygen. It becomes 9 here. Now we want our coefficient to be in integer form, so in a whole number, in an integer form. So we want to get rid of the decimal place, so we're just going to time every coefficient by 2. So time all the coefficients of this reaction by 2. So 2 times 2 becomes 4CH3 NH2 plus 2 times 4.5 becomes 9. 2 times 2 becomes 4 CO2 plus 2 times 5 becomes 10 H2O plus 2N2. Now we can see we have 4 carbons in a reactant. 4 times 3 becomes 12. 4 times 2 is 8, becomes 20. 20 hydrogens in our reactant, and then nitrogen are 4. There are 4 atoms of nitrogen, and then 9 times 2 is 18. 18 oxygen atoms in our reactant. Now in product we have 4 carbon atoms. We have 4 times 2, hydrogen. So 2 times 10 is 20 hydrogen atoms. Now nitrogen, we have 2 times 2 is 4 nitrogen atoms. And now oxygen, 4 times 2 is 8 plus 10 is going to be 18. So we have 4 on both sides, 20 of hydrogens on both sides, 4 of nitrogen, 18 of oxygen, and this is our balanced equation.